Hey, welcome to this video on, it's a review on systems of linear equations and inequalities. I hope you're having a good day because I know that we're about ready to get into some math, so I know your good day is going to turn into an excellent day, and if you were having a bad day, your bad day is going to turn into a great day. So, you're getting ready to do some math. What else could there be more fun in the world to do than some math? Especially graphing. We're going to do some graphing here. We got some colorful lines to be graphing. It's going to be pretty exciting. So strap on your seatbelt there and let's get rolling. We're going to be doing part one here today on graphing. It's a three-part review, three-part video review. And this is part one. So let's go ahead and get started. The directions say solve the linear system by graphing. And you have two equations, and you know that if you graph both of those equations, that the intersection point of both of those lines, the intersection point will be the solution. So let's look at the top equation. We know in the top equation, if we let x equals 0, y will be 6, because 0 plus 6 is 6. And if we let y equals 0, x will be 6. So there we have your two intercepts. You were just graphing or finding your intercepts. And there we have the line. And this is what we have. Now for the next one, x minus y is equal to 12. X minus y is equal to 12. If I were to try and graph that, the intercepts would be 12, 0, and 0, negative 12, and that's not going to fit on our graph. So I'm just going to make a little table right here real quick, a little XY table, and I'm going to pick values that I'm certain will work. So in the first one, if I let x equal 6, so 6 minus y is equal to 12. So we're going to subtract 6 from both sides. So negative y is equal to 6. 12 minus 6 is 6. And then divide both sides by negative 1. And so y is going to be negative 6. So there's 1 point. And for the next point, let's pick, we can go with 4. And I know, let's say 4 minus y is equal to 12. Subtract 4 from both sides. So negative y is equal to 8. Divide both sides by negative 1. So y is equal to negative 8. And there I have 2 points. And with those 2 points, I can draw a straight line. The first point is 6, negative 6. Go to the right 6 and down 6. And then the next one is 4, negative 8. I go to the right 4 and down 8. And so we're going to go ahead and graph this line. We can see there that those two lines are going to be intersecting right there at that point. So what is the ordered pair for that point? 1, 2, 3, 4, 5, 6, 7, 8, 9. The x value is 9. Y value is 1, 2, 3 down, so that's negative 3. The answer is 9, negative 3. That is the solution to this linear system by graphing. We're moving right along to question number 2. It says solve the linear system by graphing. Well, the first one, 4x minus y is equal to 3. There is not going to be a it's not going to be good to find those intercepts because they're not going to be even or whole. They're not going to be whole numbers. Actually, in either equation, they're not going to be whole numbers. So that's the reason why I'm going to change the equations. So I have 4x minus y is equal to 3. I want to subtract 4x from both sides. And I'm left with negative y is equal to negative 4x. And the 3 is positive, so I put a plus sign with it. And then how do I get rid of the negative sign? I divide, I don't know what kind of division bar that was. I'm going to divide everything by negative 1. So then the negative 1's cancel, and I'm only left with y. Y is equal to negative 4 divided by negative 1 makes a positive 4. And positive 3 divided by negative 1 makes a negative 3. And so from here I can graph this line. Y-intercept is negative 3. 1, 2, 3. And the slope is 4 over 1. So that means from the y-intercept I go up 4. 1, 2, 3, 4. And to the right 1. 1, 2, 3, 4. And to the right 1. And so I can go ahead and graph this line. And it looks like that. All right, now let's look at the second equation. I just want to subtract 3x from both sides of the equal sign. And I notice that 4 and negative 3x are not like terms, so I cannot combine those. So we have y is equal to negative 3x, and 4 is positive. So we put a plus sign with it. And how do we graph this? The y-intercept is positive 4. 1, 2, 3, 4. The slope is negative 3. We have to make that into a fraction of either negative 3 over 1 would be the fraction. So that means we go down 3 into the right 1. Into the right 1. And so we graph. And then we'll graph this line. And do you see the point where they intersect? The point they intersect was right there. And what is that ordered pair? That ordered pair should be 1, 1. So the answer to this system of linear equations that we started with, the answer should be 1, 1. If we look, I'm trying to figure out they look like the same problems, and they are the same problems. We're going to move right along then. This one right here, x plus 9y is equal to 9, and 3x plus 6y is equal to 6. I know that if I look for intercepts, I can find intercepts fairly quickly. So for the first one, if we let x equal 0, what's y going to be equal to? So if we let x equal 0, that's 0 plus 9y is equal to 9. That cancels out. So how do we get y by itself? We divide by 9. So y is equal to 1. For the second one, if we let y equal 0, we let y equal 0, it's going to be x plus 9 times 0 is equal to 9. 9 times 0 is 0, so then x would equal 9. And we go ahead and write that in there. So that way we have our two intercepts. Our first intercept, 0, 1, left and right 0, and up 1. Our second intercept, 9, 0, that's to the right 9, and up and down 0. So let's go ahead and graph that line. And it should look something like that. All right, let's look at the second equation. The second equation is 3x plus 6y. First off, we're going to let x equal 0, and then secondly, we'll let y equal 0. So if we let x equal 0, that's 3 times 0 plus 6y is equal to 6. So we know 3 times 0 is 0. So we divide both sides by 6, and we have y is equal to a positive 1. I bet you that right there is going to be the intersection point, because 0, 1 has both, is part of both equations. But remember, they could be the same exact line, so then therefore it would be all real solutions. But let's go ahead and figure out the other point so we can graph this. The second situation says y is equal to 0, so that says 3 times x plus 6 times 0 would be equal to 6. 6 times 0 is 0, so we divide each side by 3, so x is equal to 2. And we have our intersection points, or I'm sorry, we have our intercepts, x and y intercept. 0, 1, and the other one is 2, 0. Keep moving the graph instead of the line, don't I? 1 second here, I'll have it. And we are close. There we go. Finally we have it. Finally we have it. And if you look there, the green and the yellow line, they both intersect right there. And like we said earlier, that intersection point was the y-intercept at 0, 1. That was the answer. Let's look here. As always, you should be pausing the video and trying to work these out on your own, and then checking your solution with mine. So this one here, it says 5x minus y is equal to negative 5. I want to go ahead and change that to slope-intercept form. You could find the intercepts fairly quickly if you wanted to with that one, but I'm just going to change it to slope-intercept form real quick. I want to add y to both sides, so 5x is equal to negative 5 plus y. Slope-intercept form says it's y equals mx plus b, so I need to get rid of that 5 there by adding 5 to both sides. So we have 5x plus 5 is equal to y. And I know you're used to y on the left side, but this is still slope-intercept form. This positive 5 is your y-intercept. And the other 5 over 1, is your slope. So that means you go up 5 into the right one, or you could have went down 5 into the left one. Either one would have been sufficient enough. And so you have that graph. That line is now graphed. Let's look at the second line. 3x plus 6y is equal to negative 3. Let's let y equal 0. And we're going to find the intercepts. Y was 0 in this case. So we know those cancel out. To get x by itself, divide both sides by 3. So x would be equal to negative 3 divided by 3 is negative 1. And now let's find the y-intercept. So we let x equals 0, so 3 times 0 plus 6 times y is equal to negative 3. Those cancel out, and divide both sides by 6, and I didn't do a whole lot of thinking before I did this one, because the y-intercept is negative 1/2. It's not what I'm looking for when it's not what I'm looking for when I'm graphing, because negative 1/2 is not something that I can quickly graph. It's something that I can estimate on where it's at, but I can't be exact when I graph it. But in this case, it's not going to matter because I'm looking at the intercepts. If I graph 0, negative 1/2, it's going to be somewhere close to here. And I graph the other intercept of negative 1, 0. Negative 1, 0 is right there. And that's going to be the answer. Yeah, that'll be the intersection point. So that intersection point was negative 1, 0. What else could you have done here? You could have changed it to slope-intercept form. Subtracted 3x from both sides, and you're left with 6y is equal to negative 3x minus 3, and then divide everything by 6. And that really wouldn't have helped you out much either, because you still get a y-intercept of negative 1/2. And I'm not real fond of graphing unless they are crossing the grid lines exactly. But nonetheless, you can still graph it, and you can still come up with your solution. In this case, we did. So let's look here. We have these two. I'm thinking, I know that in order to get y by itself, I'm going to have to divide both sides by 8, and that's in top and bottom. So if I divide this by 8, if I divide both those by 8, the y-intercept is going to be whole numbers. So that's what we're going to be looking for, and that's what we're going to be doing. So the top one, 7x plus 8y is equal to 24. To get y by itself, we have to subtract 7x. So we have 8y is equal to negative 7x plus 24. And this is the part where I was showing you before, is that you have to divide everything by 8. So y is equal to negative 7 over 8 x plus, and 24 divided by 8 is 3. And you might say, hey, there's a fraction. I thought you didn't like working with fractions. Well, fractions for a slope is okay. It's easy to work with fractions for a slope because it's just rise over run. But your y-intercept, that's what we need to be the whole number, because we can easily graph that point right there. That point can be easily graphed. And then so for your slope of negative 7/8, that's either negative 7 over 8 or it's 7 over negative 8. One of those two. It is not with both of them, because if it was with both of them, we know a negative divided by a negative is a positive, and we do not have a positive there. We actually have a negative 7/8 in our equation. I'm going to go negative 7/8, so that means down 7 and to the right 8. 1, 2, 3, 4, 5, 6, 7 down. 1, 2, 3, 4, 5, 6, 7, 8 to the right. So from here, I can graph that line. And it should look something like this. Let's look at the second equation now. What do I have to do to get y by itself? I'm going to subtract x from both sides. And so that leaves me negative 8y is equal to negative 8, or I'm sorry, negative x, and that's a positive 8, so we put plus 8. Divide everything by negative 8 to get y by itself. And so we're left with y is equal to a negative divided by negative makes a positive. And typically we see the slope is a fraction, and then the x is to the right of the fraction, or I guess sometimes it can be a whole number with x to the right of the whole number. So what is the number on top of this fraction? Well, it's a 1. And then if we, on the right, we have positive 8 divided by negative 8, which is negative 1. So this is the equation we're graphing. So the y-intercept is negative 1. And the slope is 1 over 8, which means we rise 1, and we go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And that's going to be our line. And that is where we're at. Now the intersection point here is a tough one to figure out. If we're looking there at the intersection point, we can kind of get close, but this is why it's real important to make sure your lines are exact. And I'm looking here. I don't think that I have it exact right there. The reason why you should use rulers and make sure that you are real accurate with your points. I think it's down just a little bit. Yeah, and that looks better. Yes. Because I was up a little bit, and this white line, if you notice that this white line for the x-axis actually sits just above the actual x-axis slightly. So that's the reason why I moved that yellow line down. And so now we look at this intersection point. This intersection point is going to have an x value of 4 and a y value of, say, negative 1/2. An x value of 4 and a y value of negative 1/2. So this is review. So you've already covered some of the other ways of substitution or solving by linear combinations. And actually, linear combinations would have been the way to go here, because the numbers in front of the y are opposite of each other, positive 8, negative 8. But this review's on graphing, so that's the reason why we did it by graphing. So let's go ahead and look at the next slide here. It says 2x minus 3y equals negative 3, and x plus 6y equals negative 9. Don't forget to be pausing the video and working these out and then checking your solution. This is a review to make sure you understand what you're doing. I'm looking, I know if I'm trying to get y by itself and I divide that negative 3 by 3, I'm going to get negative 1, which is a good number for the y-intercept. So I'm going to go ahead and change this so that way I can find the slope-intercept form here. So we want to subtract 2x from both sides, trying to get slope-intercept form. And so we drop down negative 3y is equal to negative 2x minus 3. We're going to divide both sides by negative 3. Cancels out the negative 3's on the left, so now y is equal to negative 2 divided by negative 3 makes a positive, and the x goes out to the right side, right of the fraction. And then right here, we have negative 3 divided by negative 3, which makes a positive 1. So y is equal to 2x plus 1. So that means we plot 2x plus 1. The y-intercept is 1, positive 1 there. And the slope is 2 over 3. So that means you go up 2, and to the right 3. Put a point. Up 2, and to the right 3, and you put a point. And so now we're ready to graph. That's what we have. That is the equation for 2x minus 3y equals negative 3. All right. So now, looking at the next one, it says x plus 6y is equal to negative 9. I know if I try and find the y-intercept, I'm going to come up with a fraction of what, negative 1.5. So let's what can we do here? We can a couple different things. We can make an xy table. Let's go ahead and do that. Let's go ahead and find the x-intercept. So that's letting y equal 0. So x plus 6 times 0 is equal to negative 9. And I did that because I know that 6 times 0 is 0. So I'm just left with x is equal to negative 9. X is equal to negative 9. So that is the ordered pair that we're looking at. Let me get this green line out of the way. So that ordered pair is negative 9, 0 is right there. Now, here's what we can do. This says x plus 6y equals negative 9. Let me change it to slope-intercept form. So 6y is equal to negative x minus 9, and divide everything by 6. And so this cancels. So this is what we have here. Y, I'm going to write it down here. Y is equal to, now if I have negative x over 6, which means I have a negative x over 6. So the x goes out to the right of the fraction, and the invisible 1 now becomes visible for you to see. And then we have negative 9 divided by 6, which is negative 3 halves. You can reduce 9 and 6 by 3. So this is what we have, but more importantly, the slope. The slope is what we're looking for. The slope is going to be negative 1 over 6. The negative sign goes with the 1, or the negative sign could go with the 6. So this is where we're at. Now go back to that first point we put on there, negative 9, 0. Negative 9, 0. Now from that point, we can still use the slope. I know you're used to doing slope-intercept form and starting at the y-intercept, but it doesn't matter where we have a point. As long as it's on the line, it's still going to have a slope of negative 1, 6. Somehow it's going to have. So negative 1, 6. So that means we go down 1 and to the right 6. 1, and then 1, 2, 3, 4, 5, 6. Down 1 and to the right 6. 1, 2, 3, 4, 5, 6. And so by doing that, I think we've already found the intersection point. By doing that, we've already found that intersection point, so we should know what the answer is. The intersection point right here The x value is 1, 2, 3 to the left, so that's a negative, and down 1. That's a negative also. Negative 3, negative 1. So that is where we're at. I know this is probably a concept of finding the slope and then using it from the x-intercept. I know that's probably a concept you've never done, but as long as you have one point, you can take that slope and move from that one point as long as it's on the line, and you still make your line. So let's go ahead and check this real quick. I guess I didn't check this. Look at the y-intercept, negative 3/2. That's negative 1.5, right? Look at the y-intercept, negative 1.5. That would be the y-intercept. Like I said, I just don't like using that because you cannot be exact when you have fractions or decimals for your ordered pairs. And one more here for you to, wow, look at this one. Man. Well, thank you very much. We have just finished graphing a system of linear equations, and this would be the end. Don't be sad, don't be down, don't fret and don't frown, because guess what? Part 2 of the video coming up, so you don't have to be bothered by, math being done for the day. Math never ends. So this was a review. I hope you were able to get all those, and get ready for your whatever's coming up in life that has to do with graphing a system of equations. So thanks for watching the video.